Hello and welcome to the new video, and this video is going to be about this particular fitting, which is T45° entry branch. It's used in the return systems, and the thing about this fitting is that most people tend to use it with the tap junction inside Revit instead of T, which is very convenient for most of the people. The thing is, there is a limit of the ratio for the branch to the inlet of the areas of the duct, which is 0.5, and if this condition is met here inside Revit, and you can see that I have 20 by 12, the area of this duct here, it becomes 240, and if I change it to half of the duct, which is like 12 by 10, so now this is just like half. So this condition is being met here, and you can see here I have this not as an end cap, but rather this is an air terminal. As you can see, air terminal, so I have just make it like air terminal, very easy to bring the flow rate inside the duct directly. So I'm just going to have this some airflow here, so let's say I make it 1625 CFM. all right, and this one also I'm going to change it to 12 just to avoid this reducer, and I'm going to bring some airflow in this as well. So let's say I make it 725, and I have loaded this bevel tap here just similar to this, just to show. So this time the condition is being met, and if I just extend it like so, I have this bevel, and now I can do the tag for this side also, and it's going to give me the sum of the flow rates of this inlet and the branch, which is 2350 CFM. So what I'm going to do here, you can, if you select this, and you can see that you can choose the correct table here, which is ER5-3. It's the correct fitting here, which is same as of this. All right, and the thing is, I'm going to replicate same sizes or configuration here in this software, and let's see what's the the result we get. We can compare between Revit and ASHRAE here. So here the inlet is 20 by 12, so I'm going to here 12 by 20, and then here is 12 by 10, so the height is 10 and this is 12, and now I have here 1625 and 725, so I'm going to 1625 and the branch is 725. If I calculate, so it's going to give me these values of loss coefficient of the branch minus 0.64 and branch pressure loss minus 0.03, and the loss coefficient of for the main is 0.81 and main pressure loss is 0.05. Fine. So what I have to do is that I have to see what is this system. This is mechanical return air 2. I'm going to generate the loss pressure report here. I have this one, the only system. Hit OK, and I'm just going to override the previously done system, and it's going to give me this report. So as you can see is I think I did not choose the correct fitting. It should be this one, and I'll have to do the pressure loss report again. I can do very quickly and overwrite again. Alright, so this one is ER5-3, which is correct this time, and 0.808. I can compare it with this. Alright, so 0.81, which is the rounded off value of the same, so 0.801, and here I have loss coefficient minus 0.6361 minus point, which is the just rounded off value here, this one, and the pressure losses are minus 0.03 and 0.05, which is also same, 0.05 and minus 0.03 on the main and branch side respectively. All right, now the thing is, if I go back to Revit here, and if I just change the configuration, which is not 0.5 of the branch to main area ratio, so this time it will not work. and I'm going to show you here. So let's say I change it to say 16 inches this time. All right, and I will change this to 16 as well, just to avoid my this transition. So this time if I select this, as you can see that this table has vanished, it's gone now, because this condition of 0.5 is not being met here in this case. So Revit is kind of intelligent that it sees the configuration, and if that configuration is not being met, it's not going to show you even that possibility. Now the thing is that if I go back to the software, and here if I change from here this width from 12 to 16, which I did in Revit also, so the can it calculate? The answer is yes, it can calculate. So you can see it is still giving me the calculation. Now the thing is that if I do this in Revit, would it be possible? And the answer is yes, and that's what I'm going to show you in this video. So what I was going to do is I'm going to make a new system here, completely new, and let's say I have this 24 by say 16 inches duct like this, and I'm going to put some A terminal here, and I'll just give the values of flow rate here, something like 1950 say. All right, and then another duct here. So this time this duct, the branch duct, I'm not going to make it like half of this size, so I'm just going to make it some other size. So this time is 18 by 10. So if you can see that this one is 24 by 16. So if I make it 24 by 16, so the area is 384 inch square, and here is 18 by 10, and this is 180 inch square, which is not the half of this value. All right, so I'm also going to bring the air terminal here to bring some airflow inside my duct. So this one is 1950. Here I'm going to make it say 950. All right, so in this one, this is T's, and I have loaded that T here, which is like bevel T. So I'm going to just do this, and I'm going to insert the tags here and here, and you can see the flow rates are adding up. Now the thing is that let's do these this configuration in ASHRAE software first. So I have here ASHRAE software, and my inlet duct is 24 by 16, so 16 24, and the branch is 18 by 10, so 10 by 18, and my flow rate is 1950 and 950, so 1950 and 950. So this is still going to do the calculation. So I have here loss coefficient of 0.4 minus 0.4, and the main loss coefficient CS is 0.92. If I go to Revit and if I select this, the thing is all the flow calculation and loss coefficient calculations are done here inside this family. And if you come down, you see the flow rate values, and if you come down, you can see the loss coefficient for the branch side is being calculated, which is minus 0.398, and which is just rounded off. Here it's just a rounded off value, and which is also minus 0.4 almost. And this is CS, which is 0.92, I think, which is 0.92. Yes. So what I'm going to do now is that I'm going to also do the calculation, but before I do, I have to make certain changes. First of all is that I have to I have to select from here not defined, because I don't depend on this anymore. I don't depend on Revit to give me the correct or any table, ASHRAE table, because I'm doing all the calculation within the family. And the next thing is I have to make sure that all of the ducts in this particular network, they belong to same logical system. So if I select here and I see here system name, which is mechanical return error 1, and if I select here, it shows me mechanical return error 3. So what I'm going to do is I'm going to go to system browser, and I'm going to delete the logical system for mechanical return 3, which is this one. I'm going to delete it. Its color filter is disappeared, it has turned black, but it's not a problem. It's because the logical system is deleted, but still the physical system is there. I can select any duct existing for return air 1, and I edit the system and add to system this air terminal and finish. So all of the now all of the network has become the part of mechanical return air 1. And now I have this as not defined. I can go to analyze and reports. So this time I'm going to select only mechanical return air 1, hit OK, and return 01, yes. So as you can see, the pressure loss is 0.03 and -0.01, which is same as of this, 0.03 and -0.01. And now I can keep on extending this. So let's say I go this way. All right, now I have also introduced an elbow. All right, and I can choose the correct elbow type here, which is this one, CR31. all right, and now I can bring another duct here, which will become another fitting like this. So let's say this one is 24 by 16. I'm going to bring another duct here. So this time I'll bring something, say 18 by 14, let's say. All right, and I'm going to attach one A terminal just to bring in some flow rate, and this time I'm going to bring, let's say, 1050 CFM. And before I just connect it with this one, again you'll notice any new A terminal you bring into the system, it will make it for some new system. So again I have to go and delete the mechanical return air 3, and I can and bring it back to mechanical return air 1. So I'm going to view and system browser again. All right, so this is mechanical return 3. Just press delete and now select this one, go to duct systems, edit system, and add to system this air terminal. It can be added even if it is not physically connected, because that's just a logical system. So now I can go modify and extend. So now you may notice that the bevel is towards the inlet side. You can always flip it to make it on the correct side, which is the outlet side. And this is in, this is out. All right, and I can bring the tags here and here. So now let's do this calculation again inside in ASHRAE first. All right, so before I do, I'll just select this, and also again I will make it not defined, because I don't depend on ASHRAE, the Revit's capability. I'm doing all the calculations inside. So here again, so my inlet is same, 16 by 24, and this time it is 14 by 18. So this is 14 by 18, and my flow rates is 2900 and 1050. So 1050. So hit calculate. So my loss coefficient for the branch is -1.77, and the loss coefficient on the main is 0.63. If I go back to Revit and select this one and I bring it down, so you can see -1.76, -1.76, and 0.63, which is 0.63. all right, and now I can generate the loss pressure report again to see these values as well. So what I go to do, duct loss pressure reports, again just select one, only mechanical return air 1, generate, again overwrite yes, and there you go. And this time also you will see this is my 0.63 and -1.76. So -1.76 is 0.04, and which is same as of here, -0.04, and the main pressure loss with the loss coefficient is -0.63 is 0.05, if I go back here, which is here 0.63 and 0.05, so it is doing exactly same calculation as of this software. So the thing is that yes, it is possible to do this in Revit, but it won't work with this beveled tab only. So you might have to go with this family, which does all the calculation, and it's and you can, interestingly, you can go to system inspector and you can inspect the and it will give you the maximum pressure drop path also, which is the critical path. So hope you liked this video, and thanks. Have a nice time.